Right, so Algebra version B. We are sketching graphs rather than plotting them, but there are certain things that we are going to potentially need to mark on. So, first one, y equals kx squared. This is going to look like an x squared graph with x on the bottom axis and y on the other one. We've then got y equals c minus mx. So for 2, we've got our y-axis, we've got our x-axis, we've got a gradient that's negative, we've got an intercept at c, so it's going to be a line going down like that. We've then got the inverse of x squared, so we are going to have a graph that looks like this, where this is x and this is y. We then have y equals mx plus c, so we've got a gradient, we've got a y-intercept at c, and it's going up this time, so this is c, that's y, and that's x. And then lastly we have y equals the square root, y equals k square root of x. This is the inverse of this graph, so it's going to look like this, and y and x. So, which two of the above graphs are inverses? So an inverse is going to be where you can swap the x and y over, what it looks like at that point. So looking at these ones, the ones that if you swap them over, we'd be looking at these two. So for B, the inverse of I is B. Okay, so for B, what does the y-intercept represent? So we are going to need our data sheet because it's talking about a graph on our data sheet. So once we've got our data sheet, we can then look up what it's telling us about. So looking at graph B, which is this one, we've got, this is our intercept, and our intercept is when time is 0. So it's going to give us the number of bacteria at the start, which is the initial number of bacteria. Next time the semi-finals continue. So for C, the y-intercept is the initial number of bacteria, and then we've got C part 2, and where are we? There. And C part 2 in E. What do the y-intercept and the gradient represent? So we need graph E. So for E, our intercept is going to tell us the fare at 0 miles, so kind of your flat fare. So that is your flat fare is your y-intercept, and the bit that we've got that goes with that is our gradient, and our gradient is going to tell us the cost in pounds per mile. Tonight, the competition steps up a gear. And that's our gradient. Competing in teams of 4. Okay, so D. Following gives the data for pendulum length. So length is x and period is y. We've got a table, we've got square root of x. So if we go into the table function, then if we get rid of that and we get rid of that, we want the square root of x, and we want it from 1 up to 5 going up in ones. So we have this column, which is our square root of x, and this column is our differential, which we don't need at this point. So we have 1, we have 1.41, we have 1.73, we have 2, and then we have 2.24. And then we're asked to plot the values. So on our graph, we've got our first one at square root of x, y, which happens to be at this point here. We have 1.41, so 4 little squares across, and then we are going up to 2.83, so we are looking about here. We've got 1.73, so that's 3 little boxes down, and that's at 4.46. Our next one is at 2.4, and then the one after is at 2.2 and 4.47. So this should give you something that vaguely resembles a straight line. So we have a straight line. So we have now plotted the values and drawn a line, and now we want an equation of the line. So the equation of the line, if we use this point and this point, then our first one is at 1, 2, our second point is at 2, 4, so our gradient is going to be y2 minus y1 over x2 minus x1, so that is going to be 2, and so we know that y equals 2x plus c, and if we substitute in our 1 and 2, then we have 2 equals 2 brackets 1 plus c. So from that we know that c is nothing. So we have y equals 2x. Now, if we put this into our calculator, we can actually put this into stats, and if we get rid of what happens to be in there, which is our bunnies and hares on the other paper, we've got 5 points that we would plot. So the 5 points that we plotted here, which are these. So we plotted 1, We then plotted the square root of 2. We plotted the square root of 3, the square root of 4, and the square root of 5. And on our y, we plotted 2, 2.83, 3.46, 4, and 4.47. So we can just double check for our regression line. So our regression line is 1.998. So even to 3 significant figures, that would be 2. And then for B, we've got, so the exact line that we've actually got is 2.00x plus 0.00231. So actually, if you look at what we've got something pretty close. Okay, so what's the gradient of the line and what is the unit of the gradient? So our gradient is the 2 and the unit is in seconds per square root meters. So what we've got is the square root meters from the x and the seconds from the y. So that was actually E because it was plotting the graph that was D. F, gradient of the line, is 2 and it's seconds per metre cubed. And then G, given the relationship between the pendulum length x and its period y can be modelled by y equals kx, find k. So what we can do is, if we choose this one because it's the easiest set of numbers, then what we know is y is 2 equals k square root of 1. Now the square root of 1 is 1, so that tells us that k is 2. And what they will normally want us to do is the equation y equals 2 square root of x. So that actually gives you the equation that we need in part G. Right, section C. So we have Patrick and his dance shoes. So we know a couple of things. We know that we are expecting a graph that looks like this. So we have an equation, and we have a table. So if we go into the table function, and we can then put in our equation at minus 500 plus 60x minus x squared, and we want our table to be set starting at 0, going up in tens up to 60, so ending at 60, going up in tens. So we should be expecting 0 is minus 500, 10 is at 0, then we have 300, 400, 300, 0, and then minus 500. What you might notice is that these two match up, these two match up, and these last two match up. So this one is going to be the middle. So this one's going to be at the top. So we've calculated the thingy, and then we need to plot them. So 500 is our first one, minus 500, so that is at 0. Then 10 is at 0, 20 is at 300, 30 is at 400, 40 is at 300, 50 is at 0, and then 60 is back down at minus 500. Okay, we then need to join these with a smooth curve. Now, it sounds daft, but your wrist bends in this direction, so when you're doing a curve that goes up here, you can do it just controlling from your wrist. If you try and do this side, your wrist doesn't bend that way. You have to bend from your shoulder. It's a lot further away. You've got a lot less control. If you move your page round, you can still leave it in the angle that your wrist's going. So we end up with a much smoother curve. So, using our graph, we need to find out some things. So, we want to know the selling price that generates the maximum profit. So, things that we can do. If you go into graph, you should find that the equation's already there. If we draw it, if you can't see it, you want a view window that is the same as what you've got in front of you. So your view window, we've got x goes from 0 up to 60. We've got y goes from minus 600 up to 600. So we should then have a graph that looks like what you've got in front of you. So just to double check, G-solve max, we've got a maximum of 400 and the selling price is at 30. So, B part I, selling price that drives the maximum profit, the selling price is 30. The value of the maximum profit is at 400. That's that. So this is our maximum value.
It's kind of cold out there and wintry. Yeah. Does it scream?
And that is the value that gives us the maximum. Selling prices. Okay, selling prices. That has an S on the end. This is a really unsubtle hint that there's two of them. So something that gives no profit. We're looking at the zeros. And so from a calculator point of view, if you've got something slightly more horrible, you want G-solve root. So you've got when x is 10. So you've got £10 and the other one, which is at 50. Okay, and the loss if the shoes are donated to charity. So if the shoes are donated to charity, you've got a price of 0. So that is going to be what your y-intercept is. And your y-intercept is minus £500. Okay, so we are then asked to express the equation in this form. So we have nothing in front of the a in our equation. Sorry, nothing in front of the x squared in our equation. So there's nothing in front of the brackets. Then in with the x, we have the x value of your maximum point. And that is squared, and then we are plus your actual maximum, which is 400, and that equals y. So how the values of a and b are connected to the answers in part b. So a is the maximum profit, and b is unit price
So I wanted to get ahead with this.
Maximum profit.
This is pretty much done. All I have to do is chop herbs and put them in.
What herbs are going in there?
Parsley, and it has nutmeg in it and lemon zest.
So no nice tarrying and anything like that in there.
I think we've got quite a lot going on in the blue.
And what's going in the blue zone?
Chestnuts, pumpkin, and
Okay.
Okay.
And Moving on, we have another question about dance shoes.
What about you, young
So we've got a slightly different equation this time. So we are looking at plotting and drawing the graph again. So if we come out and go into table, our equation is 80x minus 4x squared minus 100. And what we're looking for is going from 0 up to 20 and going up in 2.5s. So from 0 to 20, going up in 2.5s. So our table goes minus 100, then we've got 75, 200, 275,
I feel it's both fish, just like skin and probably should have done that maybe the other way around. So there's
300,
it's not bad in portion amount.
275, 275, and then the last one will be minus 100. So what we've got is things that match up in pairs, which tells us that this one is going to be matched with this one. So this is going to be our maximum point. So then we need to plot our graph. Okay, so 0 minus 100. Then we've got 2.5, 75. Now, I'm doing this in biro purely and simply so that it will actually show up on a video. Realistically, a sensible plan would be to do it in pencil, just in case you happen to screw it up somehow. So 7.5 is going in at 275, then 10 is at 300,
We've got 1,500 square centimetres in each tray. So
then 12.5 is another 2.5,
or if we're going big, 20, 25 out of each tray.
then 15 is clocking in at 200,
So how many do you think you get out of this?
17.5 is 75, and then minus 100 at 20. So we've been asked to find a couple of things on here. So I'll join it up in a second. First off, find the gradient. So we want the gradient when x is 6. So x equals 6. Right, vaguely cheating. If we put 6 into our calculator, we are given the differential, so we are expecting our gradient to be almost exactly 32.
It does, doesn't it? I'm thinking that as well.
You know, I always say that if it feels a bit too calm, it's probably going to be too hard.
Yeah.
Now, we actually have to calculate this as well. Or we need to, if you happen to have done the A2 as well, be able to demonstrate calculus to be able to get there. So, menu, graph. Now, this graph is a different size, so we want our view window going from 0 up to 20, and it's going from minus 100 up to 300. So, should look a lot like this. If we do G-solve root, then our first root comes in at like 1.3, and our second one crosses at 18.6. So, when we draw our curve in, it should go through those as well. So we are after a smooth curve, no double lines. So if you've ended up having to redo a bit, you need to make sure it joins up. This is the joy of pencil. So heading up and a nice curve at the top. You have to have an almost flat top rather than a pointy bit. And then we are aiming for nice smooth curve going down. Okay, so we were asked about when x was 6. So x is 6 is this point here. So we need the gradient at that point. So it's kind of like balancing a ruler at that point. You want it to reflect exactly what the graph is doing there. So hopefully we've got a tangent drawn in, and drawing in our tangent is going to get us our first mark. And then we need 2 points on our graph. So our first point is at 0.60, and then we want another nice point. So ideally one that's quite far away. This one here looks sensible. So that looks just over 290. So if we call that 292, and that is at 8. So hopefully when we work out the gradient, it should equal about 32. So m equals y2 minus y1 over x2 minus x1. Now hopefully this is all going to be happy and lovely and go and do what I want it to. So 292 takes 60 divided by 8 equals 29. I'll take that. That's pretty damn close to 32.
It will be enough. It will work. Have faith.
So,
Someone needs to have faith in me.
next bit. Find x when y is 100. So, y equals 100. We can put that into our equation and go 100 equals 80x minus 4x squared minus 100. That'll give us our mark for substituting in. Then we've got a graph, draw it again. Now we know what y is, we're calculating x. So x equals GSolve xcal y equals 100. So at that time y equals 2.93 to 3SF. What's the maximum profit and what's the unit price that gives the maximum profit? That's going to be 3C maximum. So GSolve max, maximum profit, unit price that gives it to us. So max profit. So max profit is 300. Unit price at maximum is at 10. Right, hence or otherwise. In exam speak, hence basically means use what you've just done. So, use what you've just done. So 3D we have y equals q isn't in with the x, so that'll be our y value at the maximum, minus 4, which is what you found in front of your x squared,
Red 10 are seriously under.
brackets x minus value at the maximum squared. Okay, state how P and Q are connected.
It's going to come
So,
slice of
3e,
Has anyone seen the cling film?
P is the one in the bracket.
Next door, the blue team is on schedule. Before roasting the halibut, Steve fries off the longestine tails in the beast.
So,
With time to spare, Jamie has decided
we
to
have
milkshake to go with the dessert.
P is value
Fun bit of theatre.
I just think it's not a good idea.
At-
If you think about the concept, you would never have a milkshake at the end of a fish meal.
P is the value
Burger and chips. You can decide now.
of
Probably not. Yeah.
Okay, let's not.
unit price at maximum, and Q, which is outside, is
On the small side.
max profit.
Because that's very small.
Yeah.
Patrick wants to achieve a profit of at least £150.
Hold the signal
So at least £150.
from the red team and the blue team's menu.
We have got this section here.
And we're about to understand.
So we are going to want everything between about here and about here.
3 minutes, first plate.
So, values. We need to calculate x when y is 110. So gsolve xcal y is not 110, 150. So the lowest price that we could use for our unit price is going to be £3 88,
Minutes to go.
and our
Potato croquettes to bulk up her
so that is x, and then our maximum price is going to be £16, and that's 12p. So find algebraically the two prices that will allow him to break even. So 3g, break even is when profit is at 0. So when profit is 0, we have 0 equals minus 4x squared plus 80x minus 100. That's likely to be your first mark. Then, if you can remember the quadratic equation, that'll get you second mark. But what you can then do is do gsolve xcal when y is 0. So we will have a value of x that is 1.34 and 18.66. So this is likely to be a 4-mark question. You'll have 1 for the 0 equals. You'll get 2 marks for your answer, and there is a quadratic formula mark if you can remember how to work it. Okay, so Nadia staff steel beams, which is what we're expecting. We know that length is L, we know deflection is Y, and we have a single point load, and we know that W is 100. So we need to know what our cubed values are. So depending on how good you are at cubing numbers, the easiest way to do this is likely to be going x to the power of 3, and we would like to set that starting at 2, going up to 8, and going up in ones. So from our table, what we'll get is 8, 27, 64, 125, 216, 343, and 512. So complete the table, plot the graph. So when L is 2, so really not very far across.
Guys, well done.
So
That's good.
we're looking at L cubed is 8, and that is at 0.0006, so we are looking at something basically down here. Then we have 0.002, and that's at 27, so that's effectively at about 20, so about here. And L cubed about 20, about here. We've then got 64, so if that's about 50. We've got 0.005, so that's halfway up. Then we've got 125, so that's a quarter of the way across, and that's at 0.009.
It may be the most basic looking, but it's great.
So we're looking at about there.
You've got a toffee sauce across the top. I mean, what's not to like?
We've then got 0.016, and that's at 1216. So we are looking about here. Then we are looking at 343, about here. 2.6, 0.039, and 512, 0.039, 512. Okay, so we've got line of best fit, which is going to come in kind of here-ish. Now, this could be because my graph paper is fairly rubbish, or it could be they don't quite lie on a line. So we've drawn a line of best fit, and then we need to find the gradient. So, from a slightly cheating point of view, we can go into stats, and we can delete those and delete those, and there we've got 8, 27, 64, 125, 216, 343, 512, and we've got 0.0236, 0.002, 0.005, 0.009, 0.016, 0.026, and 0.039. So, if we calculate the regression as a line, we are expecting a gradient somewhere in the region of 0.1234761 x minus 0.00142. So we are dealing in tiny numbers. The benefit of that, realistically, is just so that it gives you an idea as to what you're supposed to be getting, and mostly so you don't freak out when you've got something that feels really wrong. So, finding the gradient officially, what we need to do is take 2 points that are on our line. So, tempted to go for these two. So, we know that our first point is at 8, 0.0006,
You know, I'm sorry.
and our second point is at
Team leader, but we won as a team. That was the main thing.
If it wasn't for
512 0.039. So our gradient is going to be y2
That's really to say about it, just really, really disappointed.
minus y1
Keep them like he's a team all day,
over
and then we get back in the kitchen and
xt minus
let's just read.
x1. Now, hopefully,
Sorry, red team.
this is going to give us, roughly speaking, what we got last time. So 0.039, take 0.0006 is that divided by 512, take 8, and that gives us, okay, that's impressive, 0.0000762. And quite frankly, I will take that if I was aiming for this.
Understand you may be a bit
I'm pretty happy with that. So,
pick yourself up.
given that Young's modulus for steel,
From the Holby City Challenge.
so we know that E for steel is
We
this.
want you to cook
So,
for us one.
Use our value for the gradient to calculate a value for A. So,
At the end of this, one of you will be
we know that for a single point load, that our gradient is W over 48 EA, and we know that our W
Cheese.
was 100.
Cheese is what I'm feeling today.
We know that E,
You changed my mind.
so we've got 48 times E, which is 2 times 10 to the 6 times A, and that equals, oh, missed, and that equals the value of our gradient, which was 7.62 times 10 to the minus 5. So A is going to be equal to
Especially when you've worked so hard,
100
the chances of going downstairs
divided
so much
by
higher than ever been before.
48 times 210 E to the 6 times 7.62 E minus 5.
I'll use the scraps and mix them in with a red
So A should be 1.30 times 10 to the minus 4.
It's actually the type of food I love eating. Like, I have a lot of this type of stuff at home. Love those kind of very acidic, fresh flavours.
So we've got a value of A.
Got enough energy after your exploits at Holby?
Yep.
So-
I've got a second in there, so hopefully, yeah.
We then repeated it with different shaped steel bars, so different versions of A. So what we're going to do is W is 100, 48 is 48, E is going to be the same each time, and so because that equals the gradient, if we rearrange it, what we end up with, oh no, that's A times 10 to the 6 times A. If we rearrange it, then what we end up with is 100 over 48 times 210 times 10 to the 6 times the gradient, and that will give us A.
So how do you pick yourself up?
So
You have to keep pushing on at this point because
we have
There's
100
3 other fantastic cooks in this room, and I've got to cook something
divided by
I'm going home. I'm doing some pan-fried
48
duck liver, doing some little duck hearts,
times
and then I've got some shallot and red wine tart to
210
some caramelised endive.
e to the 6 times our gradient, and our first gradient is 8 e to the minus 5. So we've got 1.24 times 10 to the minus 4. That's when we've got 5. So we've got 1.98 times 10 to the minus 4. And then we've got 1.1 10 to the minus 4, which is 9.02 times 10 minus 5. And that's it. Because we left out the sine wave section on this one, we'll do a version Z, which is just about the sine waves.